finished up a lot of vocabulary on our big picture of our population and sample, different methods for choosing our sample and collecting data. Now that we're comfortable with all of that, and let's assume we have our data, what do we do next? Next in the process is graphically summarizing your data. So let's check that out. The first thing we might want to consider is this idea of a data distribution. Data distribution has two parts. One, it gives all the possible values of that particular variable. So say all possible values of a variable. And then we also need some information on the frequency with which we would observe those. So frequency with which the values are observed. So let's check out an example of cereal. So here I've got several different cereals, and 30 to be exact. So here's 30 different cereals. These are my subjects. And then I've got some different variables collected on my subjects. For example, how much fat content each cereal has, the sugar content, and the vitamin content. Now, just a review, depending on the type of variable, we would be looking at different types of plots. So, fat content, remember our two types of variables. We had the numerical or quantitative variables, and then we had the categorical or qualitative variables. So fat content, you see this is given in grams of fat, so those look pretty numerical to me. So this would be quantitative. Just going to abbreviate here. Sugar content, grams of sugar, also looks pretty numerical to me, or quantitative. And then vitamin content, this one looks a little different. Enriched, 100%, none. So this guy looks like it's probably qualitative or categorical. So just the same way, it might make sense to talk about the average fat content, average sugar content, whereas the vitamin content we would summarize differently. We're going to also make different sets of plots depending on if the variables are quantitative or categorical. So let's start with the categorical variables, vitamin content. Now, I'm going to go through this kind of quickly because I assume you've seen this in former classes, but let's focus here. We're specifically talking about categorical data. And we'll go through two different types, bar charts and then pie charts. So let's first check out this idea of our data distribution. And remember, it needs two pieces of information. We need first the possible values of our variables. And in this case, just a reminder, we're talking about the vitamin content because that's our only categorical variable here. So the possible values that we have for vitamin content, if you flip back here, looks like we had a bunch of enriched, 100%, and then none was also an option. So we'll say our possible values were enriched, 100%, and then none. Those are our three possible values for vitamin content. The other part of the data distribution is the values it may take on, and then also how often it takes those values. And we call that our frequency. I'll abbreviate it here. So that really is like what it sounds like. Just count up how many of each. So I'll spare you. If you go back and look at the previous data table, you'll notice that there's 26 that say enriched content. There are 3 that say 100% vitamin content, whatever that definition is, and 1 that apparently has no vitamin content. That's probably like my favorite cereal in high school, the Oreo O's. I'm guessing those had 0 vitamin content, or they should have anyway. All right, so just to make sure we add all these up, we do get 30 total subjects. So the frequency can be displayed as raw totals like this, raw counts in each category, or we can talk about it in terms of relative frequency. So relative frequency is like what it says, how many in each category, 26 enriched, relative to the total 30, so 26 out of 30. You're welcome to just leave it as a fraction, don't simplify it, just leave it like that. If you'd like to write it as a decimal, you may as well. In this case, that would be about 0.866 repeating. Let's get used to keeping everything to 4 decimal places in this class for consistency. So either way, unreduced fraction, or write it out as a decimal so you have a sense that that's about 87-ish% of the data. The next one, 3 out of 30, or 1/10, so 0.1. And then last one, 1 relative to the 30 total, would be about 0.0333 repeating. And if you add up all the relative frequencies, they should add up to 1 every time to represent 100% or the whole. If you're adding up the decimals, it may be a tiny bit off depending on your rounding. So our bar chart, we're going to put our categories on the horizontal axis. So I've got enriched, I've got 100%, and I've got none. Again, all those categories, let me label this axis here. These represent my vitamin content. And then the vertical axis, we're going to represent our frequency. Here, I'll just actually use frequency. And it looks like I go from 1 to 26, so I'm going to just count by 5s here. 5, 10, 15, 20, 25. And then, like the name suggests, bar chart, you're really just going to draw a bar to the height of each category. So enriched, we had 26, so I'll go just a little bit above here. 100%, we had 3 in that category. And then none, we had 1 in that category. So there's our bar chart. Notice there's spacing between the different categories. And notice I happen to put these in order of descending frequency. That is just coincidence. You don't have to do it that way. If you do it that way, this is called a Pareto chart. So I'll make a little side note here. Pareto chart, when ordered by frequency. Pareto is an Italian, he was an Italian economist. This is often used in economy for various reasons. Not that important for us, but just an observation. And you should be able to just, very easily shows us, okay, enriched is the highest category. It occurs most frequently. Pie charts, just kind of a variation here. Again, hopefully you've seen these before, but I'll do the world's quickest pie chart here. Using the same data distribution we had earlier, we had about, well, let me try and do a little bit better. Here's the center of our pie. There's maybe our 87%-ish. So here's enriched. I'm going to put our categories in quotes here since we have a category as a percentage. That was about our 87% roughly. And then we had our remaining 2 categories. This was our none. That was at about 3%. And here was our category, it's a little bit confusing here, called 100% vitamin content, whatever that might mean. And that was at 10% of our observations. So you can, again, see the same information pretty quickly, that 87% is the category with the highest frequency. And a reminder of the terminology that you've undoubtedly seen before. Mode, it means most frequent. Category, and in this case, in our particular example, that's definitely the enriched category. One quick thing I want to comment on before we finish this that I forgot to mention here. On our bar chart, this vertical axis, I used frequency. However, I could have used relative frequency so I could see the proportions in relationship to the whole, just like we can in a pie chart. So the shape of this would be exactly the same if I used relative frequency. I would still have 86-87% for enriched, a very high amount, compared to the 10% and 3% for the other two categories. So again, shape would be basically the same, just the scale would be scaled to proportions out of a whole.